Good evening, everyone. My name is SAFIN, and I will be presenting my code for this exercise. So, for task one, the term cleaner, I'm using the code that has been given as a hint for task two for the um, cleaning up the words. Term cleaner term meaning the words are in the data set through the term cleaner will be cleaned up, as in uh, any uppercase and uh, commas or apostrophes will be cleaned out to make a single word in lowercase. And for the class term, def underscore short init, uh, it's to store the words. So self term will store the term, and self frequency will store the amount of times that it has repeated itself. And self neighbors will store the neighbors that are neighboring the words. Check neighbor is a function where it'll check if if the words are neighboring, and for the frequency amount, uh, it'll add up depending on how many times the word shows up. And for the look neighbor, this here, uh, this will check if the possible neighboring word is the same length, and and it'll pass it on to letter difference. And in the letter difference, it'll check whether if the word is different by one letter, and it will put it as neighboring words. And now for task two, import RE is importing regular expressions. So it's basically for the normal dictionaries and like anything regarding with strings and words, and that's commonly is used. And we are using the term cleaner again, as the hint suggests. Um, the class term, the defined in it, is storing the words in it's to store like words, and then the represent is used to make sure that the words are kept in it is in the lexicon is printed out the same. It's printed out as words, not as the structure of the word. And the read data, basically, um, the with open file name R as in read, so it'll only read the file and it'll like loop itself to read the next file and the next file. And for term inline split, meaning that for every word it'll split it, and then it'll put the words through the term cleaner, and then once it's in the term cleaner, it'll be checked whether it's in the lexicon or not, and whether if it is not in the lexicon, we'll put it in the lexicon. If it is already, yeah, but and then the lexicon, it's to initialize the lexicon to activate it, and the file names are the names of the files that are going to be read by the function of read data. And the term object is a loop to print out the objects that are in the lexicon. Continuing on with task three. In task three, we are asked to sort the lexicon, and sorting the lexicon for the first step is using uh, bubble sort. Now, bubble sort isn't the most efficient way to sort things. It is inefficient, and but although it's simple to understand. So import RE, import time. Time is needed. Importing time is needed to count how long it takes for the bubble sort to sort the lexicon. And term cleaner, uh, class term, uh, define init, define represent, read data, it's all in task two, and do the bubble sort part. So in this part, basically, define bubble sort lexicon. Term list is uh, making taking all the data in the lexicon and putting a term list to make sure it's the easier for us to sort it. And uh, in this section for I and j range and all of this is out the to sort out the terms in lexicon. So it'll sort out in a wide range and then it'll switch whichever words are supposed to come first and come later on. And that's happening here in the term list J. Yep. And then lexicon clear is to clear uh, uh, to clear lexicon and repopulate it with the sorted list, basically. So for term object term list, yes, it's already sorted there. And then here we have it. So here we have the start time and the end time. So it'll start when starting the bubble sort and it'll end when bubble sort ends. And here we can run the code. And as we can see, it has been sorted all from A to Z. And here we can see that it is sorted with the time. So 0.004 seconds. So moving on to hybrid sort. This sort is a combination of insertion sort and merge sort. And here we can see that the same as the first half of the code is the same as the previous bubble sort, although there's a threshold. This threshold is the amount of terms that are in the data set to choose whether using insertion or merge sort. Here we can see that in the insertion sort, you can see the term list and it'll rearrange the I is the key and it'll rearrange the key till there's enough space to fit every single term in it. And merge sort, it'll divide the term list into two, and it'll sort the the left half and the right half, as you can see here, term list left and right, first half and second half. And once it's sorted, it'll pass it over to the merge function. This will merge uh, both sections from the left and from the first half and the second half. And it'll basically take the first term from each half, or like the first few terms in each half, and it will sort it within the first, and it will go back to it will go through the list, and then whichever half has the last few terms, and it'll be in the last. So this will be much, much, much quicker. And the hybrid sort is basically for uh, the the term list. So the hybrid sort will activate if it's over 20 the over 20 terms, and it will activate the merge sort and it will sort everything. And these are the lexicon to activate the lexicon and the file names. And we have the start time and the end time too. So here we can see we can run the code and we have 0.005 seconds, which is 0.00 seconds faster than bubble sort. So in task 4, we are required to add an option for the user to pick whether they want to use bubble sort or hybrid sort. So here we have the same code as the bubble sort and then added with the threshold. Oh, this one's time. Okay, here we go. The threshold. And here we can see that we have both bubble sort and insertion sort and also merge sort here. all at once. So the hybrid sort is in the bottom half and the bubble sort is at the top half. And for the uh, choosing, so we will print out a an output saying please choose an algorithm and print out A and B, and then we can make them choose by putting choice. So they can either choose A for bubble sort and B for hybrid sort. And if they choose anything else other than those two variables, they will get a choose between A or B as a return. Will be printed out. And once they choose it, it'll print out the sorted lexicon uh, into the output, and then you will be able to see the start and end time for sorry, how long it will take for it to sort. So for example, here we can see if I were to choose a bubble sort, it'll sort it in 0.004 seconds. But if I were to sort it with B, which is hybrid sort, we can see that it's sorted in 0.007 seconds, which means it is much, much faster. Although for this, it's it's significantly faster. Although at this size of data set, which is not much, I guess, it's barely noticeable difference. Or for larger data sets, it would be really useful to be using uh, hybrid sort instead of bubble sort. So this is for task 5, and here we are needed to print out the neighbors for the words. Neighbors meaning words with only a letter difference from the term that is picked. And here we have the same code above for the reading, represent, and edit. Here we have the neighbors, which means it'll store the uh, neighbors of the term here. And assuming that the person who's going to be sorting will always choose bubble sort. So to make it easier, we choose bubble sort. Um, the bubble sort is going to sort out the neighbors, sorry, the list of in the lexicon, the term list, and then the check neighbor will run the function of identifying here. So it's gonna check if the length is equal to the word, the term that is being checked, and then it'll check for the letter difference. Here, if the letter difference is only by one, then it'll put the term into the bubble sort list. And this one is to sort out the terms that are neighbors with the term that is uh, checked. So this bubble sort list will ensure that in the list, all the neighbors are in alphabetical order. And here we have uh, the file names to print it out. And if we were to run it, we will see that it'll print out all the terms and their neighbors. And continuing on to the last task, which is task 6, where we combine everything where what we have coded and we are going to put it into one file. And here we're going to have the term, the frequency, and their neighbors. So, and it's all going to be sorted in an alphabetical order. Here we added the frequency amount, which is it's going to add up depending on how many times the word or the term shows up. And to represent, and this is going to be the term, the frequency, and the neighbor. And here's the read data. We're going to use bubble sort because it's much more simple and easier to do here. And this is a check neighbor function and the bubble sorting function for the neighbors. And then this is the write data function. So in task 6, we are needed to write the data into a file. Uh, we will name it output.txt. Here, we will be able to write the data from the lexicon into a file name. And W as write, so we're writing the file. And then here is uh, the way it's going to be written. So they're going to write the term first, and then the frequency, and then the neighbor. And here we can see that the file names are the one that are going to be scanned are these. And then we can see printing out for the bubble sort. And then here, the printing out for the sorted lexicon. And then here is the write data. So this code right here will create the output txt file. So it'll show the files that are the sorted list with the frequency and the neighbors. So if I were to run this, as we can see, we get the sorted list and we get the not.txt. Now, if we press this, double press it, and we can see that here are all the sorted list and their neighbors and their frequency all in one file. Thank you very much for listening to me explain this code, and thank you.